We have learned how to import data for various sources and formats. Now, in this chapter, we will learn how to manipulate, that is, edit the dirty data into a structured format using base_r package. First, subsetting of rows. Subsetting of rows is a very important component of data management, where the subset function helps us to pull out rows from the data frame based on a logical expression using the column names. Load a sample data like empty cars. To subset the first 4 rows and columns with empty cars, we have to pass the rows and column numbers in the format of row and columns. Therefore, empty cars 1 to 4 means 1 to 4 rows, comma 1 to 3 columns. Done. To subset specific lists of rows and columns, again we have to pass the list of rows and column positions in the format of row and column. Therefore, empty cars rows 2, 4, 6, comma 1, 3, 6 columns. We can do the same by applying a logical expression. For example, using equal to operator to subset rows which has horsepower HP 93. Now I have listed the same code with and without comma to give you an idea what will be the result if we don't use the comma. Comma indicates row and column format, just like we did in our previous examples. Else, if we don't use the comma, it will indicate the data empty cars whose columns is equal to 93, which is not accurate. We can perform the similar task using other logical operators like or, and, greater or smaller than, if else, etc. As we have discussed a while ago, we can select specific columns by passing the columns position list. Now we can also provide the list of their names instead of their positions to subset specific columns. Then we can also perform logical subsetting for both rows and columns together. Here we have defined the criteria for row subsetting mpg greater than equal to 20, comma. Now in the column format we can define the list of the columns. Also using logical operator, add a new column like if mpg is smaller than equal to 15, then categorize it as luxury. If mileage greater than 20, sports, else categorize as economy. You can add if and else again if you have any criteria and if you want to have only 2 results, either true or false, that either sports or economy, then remove this code. mpg greater than equal to 15. To remove a column, just add null to the new column. Which operator? Which operator is another very important operator that returns only the indices, that is the positions of the logical condition if true. Let me show you with the help of an example. First, load the sample data, indicate R the missing value formats using na.strings and the header. Now we will identify and save the positions whose number of doors is equal to 2 in the R object named as index position. Now we can subset the data very easily using the indices saved in the R object whose number of doors is equal to 2. Empty cars under bracket the R object name, index position, comma, leave it blank for the columns means all the columns, close the bracket, done. To do the sorting, use the function order and the columns names based on which the sorting will be done. By default, it takes ascending order, and for descending order, use the minus sign. Apart from this data manipulation, I want to show you this important aggregate function to quickly aggregate the data. Aggregate, that means average or mean. To find the average, type the function aggregate and point the columns that we want to aggregate with. Here, mpg, that is a mileage, then with cyl, cylinder, and displayed as a list. The same can be done again with another function called tapply. Or else if you don't want it in a list, just use aggregate, point the columns empty car $mpg tilde sign empty cars $cylinder and define the function parameter fun is equal to min. If we want the average of mpg mileage based on 2 variables cyl cylinder and carbonator carb, then simply add the second variable after the cylinder cyl using a plus sign. And if we want the total average based on cylinders, then only use empty cars the data set itself and display by list. Cross tabulation. Cross tabulation is another important function that uses the cross classifying factors to build a contingency table of the counts at each combination of factor levels. For example, number of empty cars based on transmission AM and cylinder CYL. Then point the columns AM and CYL inside the table function and get a table of counts for each combination of factor levels. Here 4, 6, 8 are the types of cylinders and 0 for automatic and 1 for manual. So from 32 cars, we have 3 cars that has 4 cylinders with 0 AM and 8 cars with 1 AM. Then 4 cars with 6 cylinders having 0 AM and 3 cars having 1 AM. Alternatively, we can also achieve this by using another function called xtabs. The only difference using the tab is it uses a formula interface, for example xtabs expenditure tilde category in the format numeric tilde factor 1 plus factor 2. Next, we will learn more easy way to manipulate data using a special package called dplyr.